Yeah, for those of you who don't recognize the name Coherent, I can just repeat. You probably have heard it through this show already, but Coherent is the new name of what was formerly known as 2.6. So thank you for attending. I appreciate seeing a nice audience here. I'll be talking today about coherent optics in client pluggable form factor and how those can enable IP over DWDM in disaggregated transport networks. So I'll take just a step back. My colleague Jack Su talked earlier about some levels of disaggregation at the ROADM level. Just as a reminder, what is disaggregation? What does it mean? So traditionally, optical networks were designed and built using equipment from a single vendor where all the optical elements were integrated into one system. So ROADMs, transponders, muxponders, amplifiers. You'd buy in a rack of equipment from one vendor with all those building blocks. The optical interfaces would be proprietary. The management of the system would be proprietary. You would buy it all from one vendor. And then the industry started moving to a more disaggregated model where you can mix and match equipment from different vendors. You can buy ROADM from vendor A, transponder or muxponder box from another vendor, amplifiers from yet another vendor. Of course, in order to be able to do that, you have to standardize interfaces. So you have to standardize the optical interfaces. You also have to do standardization on the management interfaces. What IP over DWDM does is take that one step further. You're taking the line optics, the coherent DWDM optics, and instead of having those in the transport equipment, you're plugging those into now your IP equipment, your routers, your switches, which means you're eliminating a whole layer of equipment down here, the transponders and muxponders, and saving tremendous cost. Obviously, still important to have standardized optical interfaces, standardized management interfaces. The benefit of this is, as I already mentioned, is on the CapEx side, you're eliminating equipment, so your investment costs go down. Smaller savings also in the fact that you don't need client optics to interconnect different pieces of equipment. But as we've been working with carriers on this architecture, we found that the biggest savings are really on the operational side. It reduces the amount of rack space, particularly if you're a network operating that's leasing space in a colo site. Your monthly rent will go down. Your electricity bill will be reduced, particularly in Europe these days where energy prices are going through the roof. That's very important. You're going to need less cooling of your equipment. You have fewer network elements that you need to plan, install, service, maintain, keep spares for. And something that many people don't realize is it's also improving your reliability of your network, because you just have fewer elements in your network. So it reduces your failure rate, and that's an operational expense. That saves as well. You reduce your mean time to repair. So in a metro environment, what are really the requirements to enable this? So there's 3 standards out there today for 400 gig DWDM optics. So there's the OIF 400ZR spec that was really developed for point-to-point DCI applications. There's OpenZR Plus MSA, and there's Open ROADM. Now, each of them have different features in terms of the reach and the form factor, and so OIF and OpenZR Plus have small form factor, low power dissipation. They do have that standardized management interface with CMIS and the OIF CMIS. But what they're lacking is the optical output power to really be compatible with the ROADM equipment layer. On the other hand, the Open ROADM MSA uses a CP2 form factor. They do have the 0 dBm transmit output power. That's necessary to be compatible with ROADM equipment. And they're also lacking, at least at the module level, a standardized management interface. So emerging category of devices is a 0 dBm ZR Plus devices. That's basically merging the best of the Open ZR Plus and the Open ROADM. So in terms of the optical specifications, it's following Open ZR Plus MSA. It's using the same FIC and framing, but it adds the 0 dBm capability of the Open ROADM MSA modules. These are now available in QSFP-DD form factors with a power dissipation that's compatible with common switches and routers. And you, again, have the standard management interface. So this is available from today, from Coherent. We're starting to see other vendors catch on. We were very grateful to win an award from the ECOC trade show yesterday for this device. It was really exciting to get some recognition for all the hard work that our team has put into this technology. So we're using indium phosphide, highly integrated components to achieve a high transmit output power and high transmit OSNR in a very small form factor without really introducing any additional power dissipation compared to low output power silicon photonics based implementations. And we have a live demo of this running here at the show, so you're more than welcome to our booth to come and take a look at this device in real life. The device has been proven out in the field. We've partnered with a carrier in North America, Windstream. They've taken this out, put it through significant amount of lab trials and field trials. So they run the device through 24 cascaded ROADMs. They run it on links, live network links, over distances of more than 1,000 kilometers, really proven the technology out into the field. They also run some successful interoperability trials with the Acacia QSFP-DD module. So they've really helped us to demonstrate that this technology is mature. It is ready to be deployed in wide scale in ROADM-based networks. So that's really in the metro regional area, how you can install and migrate to IP over DWDM to improve your network efficiency, reduce your costs. What we then see is a need to expand this approach further towards the edge of the network and get Coherent there. Now their networks look a little different, so there's not necessarily ROADMs. A lot of networks there are at the optical layer are based on fixed optical add drops. But there is a need there for higher bandwidths. Today, a lot of it is based on 10G, 25G tunable devices. But we see a clear need to upgrade there to higher data rates as well. And going from 10G to 25G to 400G is a bit too big of a leap. And the other constraint is that the equipment there generally doesn't have the QSFP-DD type of ports that you need for those higher power, higher performance devices that you saw in the previous slides. We started looking at really network needs and what are applications, and we found a tremendous amount of use cases where Coherent makes sense with the right pluggable technology. So, for example, if you're aggregating traffic, whether it's traffic from fiber to the home, OLTs, or if it's hybrid fiber coax networks, there's a need to aggregate that traffic over a DWDM optical layer, and then of course pass it on to 400G technology further up in the network. We see needs in wireless, whether it's for backhaul or mid-haul, for 5G applications, for these high data rate connections at 100G, over longer distances. Even business services where you're connecting different campuses of a business, or connecting an office location to a data center. Carriers are talking about spectral services, offering just a slice of spectrum to a customer, and they can run traffic across that spectrum. But then you're going to need a coherent device that can plug into existing networking equipment, so it has to be in that same form factor as your 100G client optics. And then another application is just aggregating traffic in just a point to multi-point fashion. And it's something you can elegantly solve with 100 gig coherent optics, combined with the 400 ZR Plus optics that we talked about in the past. The 400 ZR Plus device can be configured with a 4x100 gig Ethernet interface, client interface, and act effectively as a muxponder device. A 100 gig pluggable module will have a 100 gig electrical interface. The only difference is that the 100 gig device uses 4-lane electrical, whereas the 400 ZR Plus will use a 2-lane electrical 100 gig. So you need a simple gearbox chip in between, but it gives you a very elegant muxponder solution to aggregate traffic in a network and uplink with 400 ZR Plus into the metro. So all of these applications are out there, but of course you need a module that can fit into your existing client port. So you need something that fits in a QSFP28 form factor, and that's really critical. All the open ZR Plus MSA modules that are on the market today, they can obviously be operated in 100 gig mode, but the power dissipation is still very high. It's 11 watts, maybe even higher. And that means that they can really only plug into systems with QSFP-DD sockets with front-to-back airflow, not into any platforms that use QSFP28 client interfaces. So at Coherent 2.6, we've invested into a device with our proprietary Steelerton DSP that will bring down the power dissipation of these coherent optics dramatically. We're talking about more than a factor of 2 reduction in power dissipation of the full module. In terms of the DSP, it's a factor of 3 or more reduction in power dissipation. We've done that by really designing a purpose-built DSP focused on the application, not one of these Swiss Army types of devices that you find in the 400G modules. Really focused on just solving the problem at hand, is transmitting 100 gig of data over distances of 80, 120 kilometers, potentially 300 kilometers in as efficient way as possible. So the result is we can now offer a coherent interface in a client pluggable form factor, typical power dissipation of less than 5 watts. It is fully standards compliant, so IEEE published the 100 GBA CR spec last year. It's also backward compatible to legacy ITU standards, so we can support both Ethernet and OTN traffic. And we really think that this device is going to enable Coherent to migrate much further out in the network and make that many more links coherent and lead to wide-scale deployment. Now, for those use cases at the edge of the network, we realize that we in some cases will be plugging in modules into host systems that may not be aware of what a coherent module is. So we're also very cognizant to add some value-add features that make deployment easier. Some things like zero-touch provisioning, where you plug in the module, it will automatically find the appropriate wavelength, tune to that wavelength, and stabilize there. FlexTune is our trademark for that. remote digital diagnostics, where one module is in a host, again, that's not aware of its Coherent module. You want to be able to access the digital diagnostics, have it report what's the input power, the OSNR, so we can query from one end of the link, query the diagnostics of the module on the other end of the link, get that information back to a management system. I mentioned wireless as one application. Very critical in a lot of those applications is management of latency. Particularly, you need to know very accurately what the latency through each network element is, so that you can use the IEEE PTP protocol to synchronize clocks across a network. So we built into the DSP some latency management to minimize the uncertainty on the latency. If you look at most DSPs that are available today, there's a significant amount of uncertainty, and we think that with our approach we can bring that down by at least an order of magnitude. And then finally, we also have very standard features in the DSP, like loopbacks, and that can help with fault isolation, servicing during maintenance. So in summary, the technology is there in pluggable form factors, both at 400G in QSFP-DD, at 100G in QSFP28, to really start deploying IP over DWDM in at a large scale, and allow network operators to tremendously simplify the networks and realize unprecedented cost savings. Thank you.
Okay. We have a few minutes for questions, so if you could. Okay, that's good. Thank you.
Can you discuss a little bit the distances the 100 gig you showed can cover?
The 100 gig DCO, yes. So the IEEE spec is for 80 kilometers, really. In the default configuration of the module will support up to 120 kilometers amplified. That's then limited by chromatic dispersion compensation. We have a mode in the module where we can enable additional chromatic dispersion compensation up to 300 kilometers, but that comes at a power dissipation penalty.
Thank you. Nice talk. I traditionally think of point to multi-point as being a fiber, then going to a splitter, a passive splitter, and going to multiple destinations. But you had sort of a different definition of it up here, I think, because you had a box that was 400 gig on one side and 400 gigs on the other. Can you talk about that a little bit, please?
Yeah. I mean, point to multi-point is something people talk about in terms of aggregating traffic. So what I was showing is a use case, again, working with a partner that would allow us to use this 100 gig technology to very efficiently aggregate traffic with a very simple Mux Spawner card, very low cost. Again, it's essentially the pluggable modules plus a gearbox with very little additional circuitry around it. So it's an approach that we think can be very beneficial. And again, the key thing here is that the QSFP28 modules will plug into any existing ports with a 5-watt type of power dissipation.
We have time for one more question.
What kind of output power is supported by the 100ZR module for 5-watt, envelope?
Yeah, I won't get into specifics on the power dissipation, but we are supporting a 22 dB loss budget. I can tell you that.
Oh, okay, it's all right. I'll take one more question.
So I would like to ask you the relationship between your product and MOPA. So there is a MOPA consortium for the pluggable module for the mobile. So I would like to know, basically MOPA is IMDD transceivers. But how do you think about the 100Z, your 100Z coherent and MOPA relationship?
I mean, we are a member of MOPA. My colleague Ken Coherent is in the audience, attends the MOPA meeting. So yeah, we plan on introducing this as a potential solution to the MOPA group.
Today, so coherent technology is not included in the MOPA.
Yeah.
Come on, mate, you can tell them what.
Yeah, there's an updated technical paper on the MOPA website. It's mopa-alliance.org, and it brings in use cases as well as blueprints that are considering coherent. And there's some other topics in there that the group is discussing, as Gert referred to the precision time protocol and a lot of latency considerations as well.
Thanks, Ken.
Okay, any more questions? Otherwise, we'll thank the speaker. Thank you very much.
Thank you.